Does anybody of you know about images? What images are? Uh, does anybody know about how images are represented digitally, or what channels are image channels? Cool. And today we'll be just doing the basics. There is a lot more. I have a lot more content in these notebooks than just basics, but we'll be doing just basics. And if, or maybe we can. I'm thinking about doing some uh, more advanced computer vision things later this year, if possible. I just want to get started today with computer vision. We'll be working with OpenCV. There is a lot more to computer vision than just OpenCV. Like we also have deep learning models. We can use machine learning on images. Machine learning on images has become very powerful. Like it's one of the most advanced fields right now. Maybe we'll do that later this year. But today, let's get started. It's good to, yeah, if we do it in the single go, I don't think it will be that useful. Okay, so here you can see, now we'll be talking about images. Here you can see image of a dog, and yeah, image of a dog in a bed, and it is also edited. Uh, so how image can be represented is by three different colors. In this case, blue, green, and red, or red, green, and blue. We can call them RGB, red, green, and blue. And each of these pixels, like you are seeing your computer right now. You are looking at your computer screen right now, so you can see a color image. But this color is a combination of three different, probably three different. This is a combination of three different colors, and at each pixel there are three different intensities for each of the pixels. That defines a color. I will show you what I mean. So in this particular case, there is a this image is defined by, what I mean to say is, this image is defined by three different channels, three different color channels. We can see it as a single image, but it has three different channels. One is blue channel, which in which the intensities is for each part of the image. There are intensities of blue color, there are intensities of green color, and intensities of red color. And this intensity is starts from 0 to 255. I will show you. And these images, to see a image, they are they are stacked together. Like you cannot see these. You can see these three channels separately, but you can imagine that all these three channels, they are stacked together. And when these three channels they get stacked together, they will form this image. Okay, let me show you. Selector. Okay, so there are also different representations. We will be just talking about RGB, and I will so show you HSV, but there are also like HSL and CMYK. Okay, these are different. This is how these are scales in which these are scales, or these are techniques through which you can represent an image. You can even convert uh, from one color space to another color space. Right now, we'll be just talking about RGB. Uh, Mostly images are represented in RGB. So yeah, we'll be talking about RGB. So there are these R, G, and B values. Okay, there are these R, G, and B values. We'll be looking more. We'll be looking at them, how they are. It is pretty clear down the notebook, but you can see that here. You can see that it is written RGB. We'll be looking at this and we'll be moving around this cursor. When I go to the top right, you can see this color here. This is pure red. This color here is pure red, and you can see R, for R the value is 255 and other two colors are 0, which makes sense. If we are seeing a color that is one, we are seeing pure red this time. So all the rest of the intensities for blue and green will be 0, but for this, but for whole red image, it will be 255. And it is the images for an RGB, the scale is from 0 to 255. 0 means, if we are talking about grayscale, 0 means black. You can see 000, it means black, and 255, that is maximum of each of the channels. If it is if every channel is on 255, then we will see a white. Okay, 000 is black, 000 is black, and 255 is white. If we are just talking about a single channel image, what do we mean by a single channel image? That there are only green, there are only black and white values. Zero, there is only black and white. So 0 will be black, that is there is no pixel intensity. 0 pixel intensity means black, dark, nothing, and 255 means maximum intensity, and that refers to white. Okay, so you can see every, if I now we have seen extremes, 255, 255 for white, and 000 for black. But if you want to achieve different colors, there is like, this is some shade of red, and in this case R is 179 and G and B are 89. Okay, so this is how colors are viewed. If I change this to, uh, you can see I am keeping it at the same point here. Okay, when I change this, I go from red to green. You can see now green is on 17. You can see green here, and green channel, the pixels are at 179, R is at 89, and B is at 101. And if I slide even more, now we go to blue, you can see 179 for. So the color you see here, if you see a more bluish picture, that means that the intensity of that the pixel intensity is more blue at that point. Okay, and the color is combination of all these three things. This is how uh, various colors are seen on an image. And even if, yeah, so this is how, if I go to this corner right here, so this color is achieved by blue. 255 makes sense, there is no green and there is a little red. And if I slide it left or right, you will see the values changing. Okay, and I can even reach a 0 here. Okay, this is pure blue now. And this is some sort of a pink color. You can see red is 255 and blue is 187. So yes, this is how you achieve different colors in an image, combination of these three colors. And there are, I don't exactly know how many colors are there, how many colors can be generated using this. Here I think, yeah, you can like 255, 255, 255 for each. So I think 255 raised to power 3, I don't know, maybe. Does anybody have any questions related to this RGB pixel intensity, and did somebody not understand these channels and how image is represented? Okay, please feel free to ask. This is important. We'll be working with channels. No questions? Okay, so yeah, this is how image is represented together. And if you, just a note, if you are making a website and you need to pick color, you can always Google color selector and pick color from here. There is this hex which is used in HTML, CSS. and I don't know much about them. But yes, if you want to pick color for your website, just go to Google and yeah, select drag here, and this value will be used. There is also, yeah, you can use depending on your programming language colors, not programming language, how you program. Uh, wait, uh, there are different ways in which you define a color. So each color will have its particular hex value and HSV value as well, okay, and RGB value. So you can use these to define colors, and in different way, like I think in CSS we use hex, okay. Yeah, you can use this to pick color. And like I said, like I also talked yesterday, what images? It is just a matrix. It is just it is just a matrix, and in case of a three-dimensional image, it is a 2D matrix. Obviously, matrix are 2D. It is a matrix which are stacked up together. We, we'll see it indeed. We'll visualize it. Don't worry. Okay. So I will import all these libraries. Okay. We'll import all these libraries that we'll be needing. And yeah, we have an image. I can show you. We have this. I'm just displaying it in. I'm just displaying it in this notebook. So how can I do it? I have imported this image. You can display images using this image and give the location of the file. In this case, it is just a name because it is in the same folder. And yes, whenever you open files or do something like this, you will have to give its path. If it is in the same folder as your file, then you just need to give a name. Okay. Okay. So now we saw that there are images and there are multiple channels to these images. So when we will be reading these images using OpenCV, we'll be using OpenCV. OpenCV is an excellent computer vision library. It is very powerful, and yeah, it can be used to do a lot of things. There are around 2,600 functions, 2,600 image processing algorithms in this library. So yeah, obviously will not be able to cover. Anybody will not be able to cover all of them. But yeah, we'll be doing a very small part of it today. And yes, okay. So this is how we can read an image. This is you. This is how we can read an image. We can write cv2.imread and give it the name of the uh, give the name of the wait. Let me just sometime all outputs clear. Okay. So we can do image read, and we can give name of the file, and there is this additional argument 0. What does this 0 mean? This is a flag. So the flag takes a value of 0, 1, and -1. So if you read an image and you want to if you want to read an image, okay, and you want to load it in grayscale, so you will write 0 here. Okay, what does grayscale mean? It will not be represented by these three channels. There will be only a single channel that will be representing the image, and it will be black and white grayscale. Okay, and if you want to read the image as color image, you will write 1. And if you it is the default flag. Okay, it is the default flag. If you don't write anything here, it will be read as a color image. Okay, and if you want to read it as a grayscale, that is, you don't want to do anything with color, you will be seeing at we'll even convert images into grayscale later. So yeah, if you want to read as a color, this flag will be 1. And if you want to read image, like you don't want to make any changes as such, so what you can do is you can write -1, because there is also this alpha channel which stores some additional information related to the image. Okay, there will be three channels, or it depends. It depends on the image. Okay, how is it stored? How was the image created? Okay, but just to get introduced. Okay, what kind of options do we have? -1 is for load the image as it is. Don't change anything. Like in this case, we are changing it to RGB, and in this case, if we are using 1, we are just loading RGB. If there is a alpha channel, that will not be loaded. But if we want to load image as it is, like we don't want to lose any kind of information, yeah, if we don't want to lose any kind of information, we will be using -1. So these are the 3 flags. And like I said, yeah, yesterday, I was talking to about yesterday. We saw NumPy arrays and matrices. So I was telling you that what images is that it is a matrix. Like I said today also, it is a matrix. It is represented as a matrix. We saw this board right here, 84, 84, 18, 18. This image right here, this is a 18 by 18 image, like 18 pixels by 18 pixels. It's a very small image. And if we open it as grayscale and I print out its values, okay, I print out the image. So this is how it will look. Now you can see more clearly. It is a matrix. It is a 2D array. Okay, you can see it is a 2D array. It is a list. Inside there are other lists, and the matrix is of 18 by 18 size. You can see here in this section, in the first corner, in the top left square, all the pixels are 0. You can see all the pixels are 0. That means it will be black. And then all the pixels are white, because 255 represents white. All of these are white, and then black, then white, then black. And you can see that this checkerboard pattern is, yeah, this is a checkerboard pattern using this 18 by 18, 6 pixels by 6 pixels box, then a white box, a black box, then 6 pixels by 6 pixels of white box, as you can see right here. Okay, I will load this bigger image, yeah, so that it is more visible. So this area, all pixels has a value of 0. In this, all the pixels have a value of 255, and so on. Okay.
So in checkerboard checker pattern, black and white, why it is of 6 by 6 matrix? Why not of any other size?
Sorry, no, yeah, because it is a 18 by 18 image, because the image of 18 by 18, and it is equally divided into 3 parts, so it will be 6 by 6.
Wow.
If there was a bigger image, like if
Okay.
there was a full HD image, this matrix would be very big. This would be 1920 into
Okay.
1080. Okay, it depends on the image.
Okay.
Yeah, because to keep things more visible, I have here we have loaded a very small image, 18 by 18. Okay, just to understand things. But yeah,
Okay.
even if there is a huge panoramic image, 4K image, any image that is basically represented by these channels. This is a grayscale image. This is a single channel image right here. So this is what an image is. Does anybody have any doubts related to this? Anybody has any doubts related to this, the representation of an image? Okay, let me show you. We have another image right here, 84 by checkerboard, 84 by 84. Let me show you. I'll run this. It will be will not be able to see much. Wait. JPG. Yeah, you can see it shows just continuation, because here it will not be able to show all of it. So it just shows dot 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 dot. Okay, and you can see it starts with 0, and on the corners, as you can see right here, it is 0 on all the corners. That is why here it is just showing corners and it is 0 0. Okay.
Yes.
Cool. And there is difference between these JPG and PNG images. Keep all that. So these are compression algorithms. Will not be how you represent an image. And okay. So yeah, so let's see the size of this image. We were I remember last yesterday I told you that these things will come in handy. The shape, all these data types. Wait, so you can see that size is 18 by 18, and the data type is like u int 8. It's a 8-bit integer. Wait, yeah, I think it's a 8-bit integer. Makes sense. 2 raised to power 8 is 256, and yeah, this is a 8-bit integer. Yeah, this is a unsigned integer, 8-bit. Okay, u int. And if I want to display the image, I will do it like this, and suddenly something happened. I am plotting this image now, and suddenly something happened. You saw that here when we uh, when we opened the image, it was black and white, and suddenly it is not represented as black and white. So what is happening is we are using matplotlib here to plot this image. So you have this is just to represent that different plotting libraries or different image handling libraries, they handle images differently, because what OpenCV does is wait what OpenCV does is it generally loads image in a BGR uh, BGR. So you we saw we saw right here that we had three channels of, yeah, the image has three channels. This is red one, this is green one, and this is blue one. So whenever we load an image, uh, these channels will be like first channel, second channel, and third channel. This will not be represented. This will be represented as first channel, second channel, third channel, and using different using different libraries. They like some other libraries use RGB, but OpenCV uses BGR, and we can do conversions between them. We can do conversions between them, and there are also different color maps. I'm just introducing these things because tomorrow you will do something related to these. I don't want you to be confused. Oh my God, what happened? That's why I'm saying all these things. You just need to know that something like this, there are color maps, different color maps. There are different representations of images when you open an OpenCV or some other program or on your computer. So we need to define in this case color map is equal to gray, and it will be the same image as we saw there, and it is big. Okay. And yeah, this is the 18 by 18, the same image by using matplotlib. We have plotted this using matplotlib. So nothing to remember, just nothing. You don't have to remember it per se. Just keep in mind that there are different ways images can be represented, and different Python libraries can handle images differently. Otherwise, you may get confused sometime about what happened to this particular image. Okay, we'll be opening now this particular image, and you will see this particular image. Okay, so before this, we had just defined zeros and 255, like we were on the extreme ends. But in this case, we are not on the extreme ends. We also have in between intensities. You saw we have black, then we have some less black, then we have some even lesser black. And here we don't have completely black, we have less black, so it is getting dimmer. You can see, you can see right here. Then we have black here. So every pixel like a certain pattern is created here, so you can see that we are no longer using 0 and 255 only. There are other pixel intensities that we are using, and this is the effect of that. Okay, this is the effect of that. So again, like we saw right here, that changing intensities, like going from more pink to less pink, or going from less blue, this is white right now, going from less blue to more blue, we will see that 255 is increasing. It is increasing like wait, what is happening? Yeah, when we go from right to left, you will see that intensities are changing. Okay, intensities are changing, and similar thing is happening here. Okay, pixel intensity changes. It is different. Now you can see different effects here. Okay. Any questions related to that? This is anybody who didn't understand? Okay, how this image is represented, or why it is represented this way? Okay, so next, working with color images. Okay, now let's open a image. In this case, this is a Coca-Cola logo. Okay, so this is our image. We can see it right here, and let's read it using. Let's open this using OpenCV, and how you can open an image using OpenCV is cv2.imread. We saw this before, and we have written a 1 here. What does this mean? What does this flag 1 mean? Does anybody remember? What does this flag 1 mean? We have written 1 here. There are other options like -1 and 0. We have written 1 here. What does this mean?
Sir, it loads the color of the image.
Yeah, it loads the image in color. Yeah, good. And when I run this cell, you can see that image size is 700 by 700 by 3. So this means that it is 700 by 700 pixels, and there are 3 channels. Okay, and the data type is. Can you mute yourself, please? Can you mute yourself, please? Thank you. So you can see that the data type is still unsigned int, 8-bit integer. Okay, so yes, if I do a 0, let's see, you can see that now the image is just 700 by 700 because it converted the image into a grayscale image. And let's see if I do -1, what will happen? It is same because there may be no alpha channel in this case. So yeah, let's load the image in color. So 700 by 700 by 3. Now we'll do it again, and you can see that this is exactly what I was talking about. This is no more red. Here we loaded the image as such. Okay, this is a different function, but this all these functions are here because to make a point. This is the image as itself using some other thing where uh, now when we now when we uh, now when we loaded the image now when we yeah, we have loaded the image using what do we load the image using? We used imread. Okay, we used imread, and like I told you, OpenCV opens the images as BGR images. First, the pixel, first it show the first channel it assumes is blue. The first channel is blue, then green, then red. But when you use matplotlib to plot these, it uses RGB. Okay, it uses RGB. It is written right here. This is because matplotlib accepts the image in RGB, while as OpenCV stores in BGR format. So these are two different ways in which the images are stored. That is why that is why the pixel here it is consumed. We know if this image is in RGB, makes sense that the red has the most value. Okay, makes sense, right? It makes sense. Red RGB, R has the more value, and this is a RGB image. But when we opened it using OpenCV, it was loaded as a VGR image. But now when we are plotting the same thing, and this accepts a RGB, so red channel, this mistakes is at not mistakes it the blue channel values. It thinks, okay, this must be the blue channel, the blue channel values are, according to this, the blue channel values are now 255 because B it loaded as BGR. Now this is RGB. So B and R are getting swapped. It thinks that this is a blue pixel values are 255, but we know that a red pixels value should be 255 in this region. So what we can do is we can convert from BGR to RGB. So there are two syntaxes to do this. You can do this slicing operation, and then this means to select all the channels and then use -1. That is inverse. RGB will be converted into BGR. But there is one other method you can use is CV2 OpenCV method, CV2.cvt color. You will give the input image, that is Coke image that we used above, and then convert it from cv2.color BGR to RGB. Okay, now we are converting it into RGB, and now matplotlib gets the proper image and it is read back again. Okay, does anybody have any doubts related to this? What I was saying? Because everything is in sequence. Does anybody have any doubts? It is not possible that किसी को doubts नहीं है. Somebody must have doubts with whatever I said.
So can you open the previous screen, sir? Sir, सर CV2.cvt कलर कोक इमेज, सर ये आर्गुमेंट किस चीज का ले रहा है?
हाँ, ठीक 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 ठीक. Yeah. So I think this will come again, but yeah. So this is a function. This is a OpenCV function. Like we had length functions, we had copy function for lists, uh, we had sort functions for lists. Similarly, say OpenCV has a lot of functions that come in really handy for you. So this is one of those functions, and it has two arguments right here. I think it has okay. It has two arguments right here. One is we are giving the image. Okay, we want to perform
Okay,
operation on this particular image. Okay, we opened this image right here, Coke image. Okay,
okay,
now we are giving it Coke image, and we are asking it what this is the operation cv2.color bgr, that is bgr से convert it from bgr to rgb. Okay, mnemonic naming again right here, cv2.color bgr to rgb, convert it from bgr to rgb, and then when you just plot, we saved it on Coke image channels reversed. This is again mnemonic naming, and then we plot this image. Okay, now we have converted back from BGR to RGB, and now matplotlib can, yeah, show you this image like this in its correct form.
okay.
Okay.
सर मैटलैब का जो लाइब्रेरी होता है वो भी मैटप्लॉटलिब से डिराइव रहता है क्या?
सॉरी क्या कहा तुमने?
सर मैटलैब का जो लाइब्रेरी रहता है प्लॉटिंग का, वो भी मैटप्लॉटलिब से डिराइव रहता है पाइथन के?
नहीं, दे आर टू सेपरेट थिंग्स. आई वुड थिंक उल्टा हो सकता है, बिकॉज आई थिंक मैटलैब हैज बीन देयर फॉर अ लॉन्ग टाइम. Yeah, most of I don't know if what is derived from what, but yeah, they perform many of the same things.
Yes.
Okay, so yes, for plotting, like my MATLAB में plotting options होते हैं तुम्हारे पास, you have plotting options by default, but in Python you use matplotlib. There is also one other plotting library, I don't remember the name, but yeah, matplotlib is used everywhere. Okay,
Yes.
so yeah, now we have this another image. Let me show you what this image is. So this is the image. Okay, now we'll be working with this image. This is a New Zealand lake. Okay, this is a lake somewhere, and we'll be working with this. Now we know that this image is a color image. It must have 3 channels to store different pixel intensities, RGB. So now what we'll do is we'll be separating this and seeing, okay, how does each channel look like. So the image is right here. We just saw it. Okay. Now we'll be working with this image. So what we are doing is image New Zealand BGR, and we'll be loading BGR because OpenCV loads is as BGR, and you can see that we are using IMRead. Okay. Now cv2.imread color. Right? You can see that here it was written cm2.imread color or 1. In this case, it has where did this go? Yeah. So it has written here cmread imread dot color. We can even write 1. It is the same thing. Same thing, different representation. Sorry. Yeah. Okay. So now using the split function, the image is loaded as a BGR image. We'll use the split function, and we will store all of these in separate variables B, G, and R. Now we have three channels that will be separated using BGR. This is just the simple things that we have been talking about, but now we'll see. We'll see. Okay. We'll see now what actually is happening. We'll see it on a real image. So this is how you plot. You initialize a figure, and then you have different subplots. You initialize a figure, and you have this is the syntax for plotting. You will see the plot type for plotting images in this case. So what we will do is this is just defining. Okay, this is plot one, subplot two, subplot three. In this case, and subplot four, and for each subplot we'll be using like this plot.imshow. We are using this plot.imshow to map images separately, but why to do it in a combined way, this is the syntax. Okay. we'll be uh, we'll be printing we'll be displaying red channel, green channel, and blue channel, and then we'll also be representing the image, the combined image. And we could have directly printed the image right here, but we are also to introduce the merge function. You can use cv2.merge and merge all these three channels. It will be the original image that we just saw. When I run this, the red channel pixel intensities of red channel looks something like this, and this is color mapping, gray color mapping. Gray color map, we are seeing each channel in grayscale. Okay, so this is how red channel looks in look. How does the red channel look like in grayscale? And this is the green channel. You can see that all these three channels, when you look at them in grayscale, they have different things have different intensities. You can see in red channel the sea looks more like it has more contrast as compared to this green channel. Okay, we can see in red channel we can see shadows. Right here we can see shadows, but these shadows are missing in blue channel. There are less shadows in green channel. Okay, so different channels have different information, and this comes in real handy, because like if you are working on a yeah, this information, that different channels, you look through the channels whenever you are trying to do something, you look through the channels. I remember I was working on a project. It was regarding finding lanes on a road for autonomous vehicles. So we uh, uh, some of the channels, they store more information for particular things than other channels. So we had to find out, look at the each channel, and then see, okay, this channel represents our information, and then we used to work with that particular channel. So this is important. We are just beginning with the basics here. So this is important, that different channels may contain information. For example, if you want to work with maybe some of these shadows, so these shadows are visible in this red channel. These two channels, they are not visible there. So this red channel will be useful to you. Okay. This was just an example. Okay. So yeah, this is the output, the image that we saw, and these are the individual channels in grayscale. You can see that there are different pixel intensities for particular color. Okay. Now, does anybody have any question related to this? You are just being introduced here to different things that you can do with OpenCV. Different functions like we did with basic Python. We had to learn all the data structures, all the methods. Not all the methods, important methods, so that we can get started. Yeah, good.
Sir, in image merge function, sir, there is this double colon, sir, that is scope precision something. Sir,
Yeah,
वो क्या है?
what this is, what this is doing is, I told you, I showed you before, right here. Uh,
Yes, sir, you have showed us.
yeah, yeah, I will talk about it again. Wait. Where is it? Yeah. So right here we know that in OpenCV it's BGR and in OpenCV it's BGR and in Matplotlib, because we are using Matplotlib to plot these images together, and it is RGB. So this is the syntax for going from RGB to BGR, like kind of flipping it. Not exactly flipping it. Flipping it would be long, like to reverse the channels.
Okay, sir.
Remember yesterday we were doing with NumPy or list. What we were doing is we were we were we were reversing it, reversing the
Yes.
list. Yeah, this is exactly how you do it. You can do it either by reversing the channels, because we know RGB. If we reverse it, it is BGR. BGR is reverse RGB. This is the syntax for that. Or you can do this conversion. Okay. So this is
Okay.
exactly what is happening here, because we have this a BGR. We have this BGR image right here. We have this BGR image right here. But we know that Matplotlib is in RGB. That is why we are just flipping this image. Okay. We
Yes.
could use the CV2 color BGR to RGB, but yes, we chose this one right here. It is the same thing. Okay,
Yes.
so this is the output. This notebook, you there is everything written on this notebook, and there are this is actually the official. This is actually the official tutorial of OpenCV. Okay, you can yeah, there is all these this notebook is uh, there there is a lot of things written in this notebook, and there are a lot of links that you can go and find out more things about this. Okay, so now we'll be seeing converting from we'll be going to different color spaces like RGB to BGR. How do we do this? Okay, so the syntax is we saw it. We give an image. We call this function. We give its input image, and the output is b. And this is the output. Sorry, this is not the output. This is what we want to do. In this case, we want to go from BGR to RGB, and then using Matplotlib, we'll plot this. Okay, this is the same image that we. So this is how you go from BGR to RGB. We saw this before. Now there is this another color space, HSV. It is called hue saturation value. Wait, I'll show you hue saturation value. So this is also how you can represent image. I will not be talking about this. Sorry, but yes, like we had RGB right here, 250, 250, 250, 20 to 255. Hue saturation and value. It is. I'm just showing you this. This is uh, this is a kind of the model for it. You can see it right here. Okay, I don't even remember much about this, but yeah, this is a different color space, and this color space we change from color spaces because the because information is stored in different color spaces differently, and in my case, I used this HSV because I had to find the lanes on the road, and the lanes were more visible in HSV. So yeah, we there is this another color space. HSV. Just remember this. There are more even more color spaces. You can see it right here. Okay. So what we'll be doing is we'll be seeing all these color images. So you can see that the we loaded the image. We converted it from CV to color BGR to HSV. Sorry. We converted it from BGR to HSV, and now we'll plot this. We separated the each of these channels using the same methods, and we even, yeah, okay, we plotted them. So you can see that hue, saturation, and value. Hue, saturation, and value. The information is totally different. Image is the same. You can see that there is no change of image. Okay, original image is the same, but when you change it to different color space, you can see different things are represented differently. You can see now mountain is not visible right here. Okay, mountain is very vividly represented right in this channel. And this is again, whatever information you have to find, maybe you are looking at some sort of a structure. Okay, for example, you took images of your test sample, like mechanical, uh, you want to see the grain structure, you took the photos, and you want to see, maybe using these channels, using these vision techniques, you will be able to find more information related to all those grains, maybe. Or yeah, so you just need to know, okay, something like this exists, because you can see, you can view different things differently. In this case, this beach, this looks very, like, I think there is very high contrast. This looks very dark. And in this case, the mountain is not very visible. In this case, mountain is visible. So different information you can find, it can be useful to you. So this is how you can look for information in a particular image. Okay. So these are the ways. So this is also, yeah, this is also how images are represented. And the next thing is, now we all know what is all this, what is all these, what are all these things. These are just matrices. Like we saw yesterday that we can do matrix operations on uh, we can do matrix operations. You can do the same right here. So what you are uh, modifying in this case, the edge channel, what you did is, you, for each pixel, it has some value. It has some value. You can see right here, it has some value, and for a particular channel, you are changing. In this case, for who channel, you are doing addition. Okay, you are doing addition, and you, when I plot this, you can see now edge channels looks a little different. We can do 50 to see more difference. Mm, wait, wait. Modified CRGB. Just V to RGB. Wait. Just V to RGB. Yeah, so you can see the modified image. This was the original image. This is the modified image. The more change I make here, you can see. Yeah, this image is getting modified. So what I'm doing here is, I'm changing the pixel intensity in hue one. You can even do it in H channel and S channel. S new, I can do something like this. S new is equal to S plus. So what will be happening this way is, each of the elements of S, it will be uh, there will be an addition. Okay, so you saw the image changed. If I do 0, you'll see the image looks different. It looks lighter. But if I do like 50, it looks a little more darker. Okay, so you can play with these color values, and you can see in, say, different information. You can get now different information. Your beach got separated. The green plants, not exactly, yeah, these were plants. These plants got separated. Okay, so this way you can, all these modifications are, this depends on your situation, particular situation, what you are trying to achieve. Does anybody have any questions? Please feel free to ask what is happening, for syntax questions or some other type of questions. You must have questions. This can be the last session of this workshop, by the way. Okay, so let's move on to next thing now. Now we'll see how we can save images, because if we have done all this editing, and this is editing, so if we have done all this editing, we'd like to save these. So we would like to save this image, uh, New Zealand BGR. So what you will write to cv2.im, right? And what how you want to save the image. Here the name of the image. You can even write JPG here. Okay. PNG has more, like, it has more data. It's have more high quality image. So pass in the image, pass in the name, and the image will be saved. Like, I'll show you if I write Lulu, because this image is already saved here. If I go here, you can see that an image named Lulu got saved. Okay, so I was not kidding. Okay, let's try to image. Let's try to save this image. Okay, cv2 dot write image. I want to save this one, modified one. Let's see. Yeah, this is, now you have a different image. The plants were not green before, now they are green. Good job. So you have different information now. Okay, so yeah, you can even see its image, see its size and everything. Okay, this is the same thing that we did. Okay, we saved some images, we did all of this. Great. Now, does anybody have any questions till now? Okay, somebody who's not able to, obviously there is someone who is not able to understand. Obviously it is difficult to get a grasp of all of this, uh, when you have just started learning Python. For most of you, I think you are beginners. So yeah, please do attendance. Mark your attendance, please, and we'll move on to the next thing. Next notebook. There is a lot more stuff. Mark your attendance.
I think it's done. You can continue.
Okay, cool. Mm-hmm. 4, 8, 2. Okay, so now let's do something interesting, a little more interesting. We were talking about things like channels as they were not visible, much visible to us. But now let's do some things like, you do on your, like, We do all of these things, like we do crop, we do editing of images. So let's do it using OpenCV. I hope this will be a little more interesting and you can see the results yourself. Okay. I'll be using some, you'll see how slicing and all these operations are used to, yeah, crop images. The things that you were doing in lists, that you were slicing the list, now you will be slicing the images, and that is it actually what crop is, cropping an image is. Okay, let me just clear all outputs, import all of these. Okay, so we'll be again working with that checkerboard image, 18 by 18, that small one we know. Let's print it out. This is exactly, yeah, this is it. Okay, now what we want to do is we want to, uh, we want to, now what we want to do is we want to access individual pixels. What is the value of this particular pixel, and we'll be using exactly what we learned yesterday. So we have used this image, CB image. Okay, wait, I want to forward. Wait, I want to see something. Wait a minute. Yeah, you can see right here that this is a NumPy n-dimensional array. That is exactly what we did all these operations yesterday on NumPy. I was saying that images are also, in this case it is a two-dimensional array, the images obviously, otherwise it will be a single line. So will be using exactly those operations. Like if we want to get to know what is the first pixel, we'll just write 0 and 0, 0 and 0. You can imagine what exactly this is. This means that 0th row and 0th column. Index 0, index with 0, row with index 0 and column with index 0, and this is the intersection of it. This is the particular element that we are talking about. And it has also written 0 or 6. This is the seventh element with 6, with index number 6. So this is what we'll be printing out. Okay, so when I run this, uh, first pixel is 0 and seventh pixel is 255. Okay, now we'll be modifying these pixels. Okay, now we'll be getting, or we'll be doing something interesting. Okay, we'll be changing these pixels to 3, whatever, and you saw that we are using a copy of this so that we don't change the original thing. Okay, so we are making a copy of this checkerboard image, and we are changing these particular pixels 23323. We are changing it from, what was it, 2223, I think it was 0, and we are, yeah, you can see right here now these pixels in this right here, they are no more 0, they are 200. Okay, and we did this manually. Okay, we did this manually. We, for these 4 pixels, for at these 4 locations in this two-dimensional numpy array, we changed from 0 to 250, 200. Okay, so what is 0? 0 is black. Okay, what should you expect right now in this image if we change it from 0 to 200? It should be brighter there, right? It should be brighter there, and then you can see, oh yeah, this is not black anymore. So this is how you just modified a matrix, you just made changes to a matrix, and then we matrix represented an image. I hope you are getting more a more better idea of, okay, what image actually is. Okay, so this is now somewhat gray, and if I write 255 255 right here, if I don't change it to 255 255 255 255, you can see now the image will be completely white there. Okay, so this is what is happening there right now. Okay, and yeah, this is the same operation. As you can see, this is just slicing, and you are just using more than, yeah, you are not just using a particular indexing, you are using more than particular index. Okay, yeah, save the image copy, yes, exactly same. Cool, because 3 will not be included, it will be just second index. This is same as this one. Okay, Let's change it back to where it was. Okay. Now, how can we crop the image? Again, we're loading the image. It will be loaded as RGB, BGR. We're flipping it, not flipping it. We're converting it to, we're reversing the channel so that it is by matplotlib. It is shown as this RGB. Now, what we want to do is we want to crop out the middle region. Okay, let's do it like this. We want to crop the image, like we want to focus on this spot. Okay, we want to focus on this spot. So how will we do that? Mm, how will we do that? We'll be using the same thing that we did yesterday and even in lists. Okay, we want to particular uh, think about this also. What was happening here? Okay, so does anybody know what will happen if I do this? Hmm? It will be the same image because I'm selecting all rows or columns. Okay, it will be the same image, but what we want to do is we want to crop it. Okay, so you can see that we have written all the pixel intensities are written here. We want to some like this area of interest. We can see that this starts from one, let's say 150 right here, and then this ends at somewhat of, I will write 450. I'll write 450, and then here, let's say from 250 or 250, and it is somewhere at 600. Okay, so you saw that it got cropped. Okay, I just randomly cropped it here in this notebook. It is, there is a different crop, but yeah, you can see I just counted. Okay, I just counted. Okay, I just want this portion, so I went here. This particular axis is shown by this is on the left part, and this particular axis, it is right here. Okay, you can imagine rows and columns. Wait, okay. Does anybody have any problem with this crop? How did this crop happen? We are just slicing the image, which is an umpire array and dimensional array. In this case, two-dimensional array. Does anybody have any problem with this? What is happening, or how did this happen? Does anybody have any problem with that? So whenever you are doing crop on your phone, just remember when you are dragging it around, you are just telling it, giving it these values. Okay, 150, 450, 250, 600. Okay, whenever you are doing the crop. So now you can imagine how the crop is happening. It just discards the rest of the array, and this is what you are left with. Okay. Okay, so next thing now. Now we can also resize the image. We can increase the size of the image. Okay, so the function for that is cv2.resize. Okay, and we'll be, in this case, we'll be taking the cropped region is right here. Okay, right here, and we'll be resizing it. Okay, we'll be resizing it. We took the cropped region and we wrote none here. What exactly is this? Output size image, wait, SAE output size image. Okay, we are writing none here because the size will be defined using this, fx equal to 2, fy equal to 2. This means कि किस direction में कितना बड़ा करना है इसको. In this case, we are doing in both directions 2 times. So if I do this, this is the image, and it looks the same, but you can see it goes from 0 to more than 350 and 0 from more than 500. And in this case, you can see that it is from 0 to, it is half of that. Okay. uh, it seems the same, but yes, you can here, yeah, the pixels, it has more data, like you have increased the resolution. Although there may be other effects, it's not like you will just put a photo and increase resolution. There may be some loss of data, like some additional data, which is not, this is not always good, but yeah, you can, this is how you can increase the size of a photo. Okay. You are kind of, I don't know if you are from, if somebody is from electronics background, you are upsampling it, which is not, maybe which is not the best idea to do. But yeah, see, this is how you can do it. Okay. And you can also do it like this. Before this, what we do is, or what we did was, we did not, we just wanted it to, we just wanted that the image should be of double size. But you can also define a uh, particular dimensions of the image. In this case, whatever the dimensions were, we want it by 100 by 200. So we define these and we create a tuple. Okay, we create a tuple here and we pass in the tuple right here, the same image. And yeah, this is you can see now it's 100 by 200. Okay, but now the image is skew. No, not skew per se, but yeah, the image is not appropriate because it has lost some information related to lengths and widths, because the aspect ratio was not maintained. Do you know, guys, know about the aspect ratio? Aspect ratio is just whenever you take an image, it has a particular aspect ratio, like
Length and width ratio, sir.
yeah, length and width ratio. Yeah, the length and the width ratio. If you want to maintain that length and width ratio, what you can do is, you can do something like this. Just preserve, you define the desired width and you define aspect ratio. Okay. And then desired height would be integer of cropped region shape, that is its shape 0. That is, means in this case would be, what would this be in this case? Let us find out. Let us find out. So this is just a simple operation. Wait. What happened? Printed cropped region 0. Okay. This is the problem. Okay. So yeah, in this case it is 200. In this case it is 200. Wait. Cropped region shape. Cropped region. Let me see. One moment. Cropped region. Which image are we using? I'm just trying cropped region. Cropped region. Resized cropped region. Resized cropped region. Yeah, in this case we have, this image was, it has, I think it was 200 by 300. I think 200 by 300. Maybe it can be 350 or, yeah, let's see. Print. We can always check using this. Okay, yeah, it was 200 by 300 by 3. 200 by 300 by 3 image. Okay, so this is just a mathematical operation, so that this is what we are doing here is, this is nothing special. We are defining the dimensions using, we define a width, and to maintain the aspect ratio, we find out, okay, this was desired weight divided by crop region shape 1, so that it is in the same ratio. We are just defining the same ratio. You can understand the math. uh, uh, if you don't understand the math, take a look at it later. What is happening is, desired length, you want to maintain the aspect ratio so that your desired height is if is multiple of its aspect ratio. That is exactly what is happening right here, and then you give in the dimensions. Okay, so this is just maintaining the aspect ratio, which is important for most of the images. Okay, let's actually show the cropped resize image. Yeah, so this is your image. Now we have saved it. We have saved the we have saved this one, and we have converted into from BGR again to RGB, and we have saved it right here, and we are looking. This is the image, your cropped final image that we did some operations right here. Where is 2x1? Yeah, this one. We are saving this particular image. So this is how, after doing all the operations, you can save the image. Okay. This is the same thing. Cool version. Yeah, no problem. Now let's do some more something even more interesting. Okay. Now we can flip the images. Now you can imagine of these flipping of the images. This can be thought of as you are you are doing various matrix operations. You are not changing the image exactly. You are not changing the pixel values, but you are changing those pixels values of those pixels location, like you are doing transpose, or you are doing multiple operations of those sort, but not changing the not changing the pixel values. So how you can do that is, you can use this cv2.flip method, and in this it has a second argument, pass in the image. First you will pass in the image in this particular function, and then there will be 1 0 or -1. For 1 means horizontal flip, 0 means vertical flip, and -1 means that you are flipping it on both uh, in both directions. Okay, now you will see this is the original image. Horizontal flop, you can see this was pointing, in this case it was pointing towards left, now it is pointing towards right. Vertical flip, you can see the boat is now, it's pointing downwards, and in this case it is pointing downwards and towards right, towards left. Okay, so this is how you can flip an image. Okay, I'll just show you now how you can open the camera if you want to work with your images, if you want to work with your own images or your own video. And what you can do is, you can also, and I'll finish this. I'll finish this right here, because I think it will be a bad idea to say too many things. You will that you will forget. I don't want to overload you. Maybe we can keep a session, one more session, maybe next week. Can you guys tell me, can we keep a session next week so that you have some time to settle all these things in, or maybe even revise? Can you please? Should we keep a session next week? I will show you how to use your camera, webcam, next, and then we can finish. Okay? Or do you want to be done? Do you guys want to be done with this workshop?
No, sir. One more day will be best. We have missed a one class now.
Okay. Anybody else who has any? If you have any suggestions, please fill that feedback form. If you want to work on something more interested, because like I said yesterday, up to yesterday, what we were doing all the necessary things, but now, but now. Like, depending on your feedback, or like not that feedback, in class feedback, okay, what kind of things you are able to understand. Like, if this seems very easy for you, we can go do advanced things. Or like normal people, if you have just introduced to this topic, and obviously it will not be like clear, so we can stop right here, and maybe you can learn this thing, revise this thing, and maybe in 2 3 months or 4 months we can do something more advanced. So yeah, you can write that in the feedback. You can give me anonymous feedback related to this if you want to do that. We can arrange something. We'll even go to we can even go to, if we can even go to some very good computer. We can work on some very good computer vision projects that are very advanced. Yeah, give me your feedback, and I will see if I will. Regarding the next session, I will see if if I if I will hold one more session, but not this week. Maybe next week. Okay, because this is just the introduction. We are just scratching the surface. There is so much to it. There is so much that I don't know, but I know a lot more than what I am showing you right here. So it will be I would really enjoy telling you all these, teaching you all these things. But yes, the interest should be there. So yeah, please let me know. And okay, let's go on work with our let's let's work with our camera. And I will give you, there is a one YouTube channel I will tell you about. It's Murtaza's workshop. He has some very good, very amazing computer vision OpenCV tutorials. You can after this you can go to that and work on the projects that he teaches. Okay, those are very interesting projects, like using your hand as your mouse, like making a document scanner, all those kinds of things. Using this, like this will be the starting point for all of those things. Okay, so let me share my screen now. Accessing the camera. So this is the script for accessing the camera. It cannot be run through Jupyter Notebook. That is why I will open it. So what we'll be doing, we'll be opening CV2. You will be importing CV2 in our script, and then our source will be CV2.video capture 0 means that will be using the camera. Let me turn off my camera here so that this script can use it. Wait. Okay, and then we'll name the window, in this case camera preview, and we'll go into a while loop, and while loop will end when we press escape. So this is the syntax for that. While cv2.wait key not equal to 27, the loop will be running. S27 means escape. There are also other syntaxes. Okay, we'll have one more session and we'll talk about those syntaxes there next week. And yeah, so until you press escape, has frame means if the camera is on. It checks if the camera is on. If there is some problem with camera, this while loop will break and everything will go out. Otherwise, if we have some incoming feed from the camera, like if your camera works and everything, you will show uh, there will be a window right here, and you can use this, and whatever we saw today, you can use this frame. Okay, you can use this frame, and you can apply all those things. You can turn on your camera. I will show you. You can turn on your camera, and right here, just before showing, you can do all the operations from this frame. And then you can convert from BGR to RGB. You can convert your camera image to HSV, and then you can just show the HSV here. Whatever we did, you have to replace all of those. You can replace all of those things here, and that will be visible to you on your screen. In this case, I'm not doing anything, so you will just see my face. Let me run this. And how do you run? You have to go to. I did not show you the guys this. So we have a Python script, a normal script in our computer somewhere. First thing that we will be doing is we'll go to this particular location, folder location. This is how you run Python scripts. I use this Anaconda prompt. You can use command prompt. Okay, I will go to this particular directory. You may even have to write down the whole directory, but yeah, it is very important to go to the particular directory. Okay, now I'll write Python. This is how you run Python scripts. I'll have to run Python, and then I will write the name of the file. In this case, is 05 camera. Yeah, please do. This will be interesting. This will be interesting. Opening your camera, looking at yourself, and doing various operations. I write the file name .py, and when I run this, I'll wait now. Yeah, so this opens. Hello. Okay, so this opens. You can do anything here. You can convert it into HSV. You can do a lot of things with this. Okay, and when I press escape, the program will stop. Okay, this while loop exists until we press escape. Like it will be an infinite while loop, and then source dot release and destroy all Windows name. Okay, so this is how this is necessary to do these things. Okay, to yeah, to free your RAM. Okay, anything that you guys want to anything you guys want to say? Hmm, hmm.
No, sir. Nice option, sir. Nice option to use the webcam.
Yeah, you can do this thing now. Now, with this, things get more interesting. Uh, let's do something like this. I hope this works. Let's do this. Let's do this. Let's do this. Let's see if it works out. I think it should, but we'll be finding out soon if it works. Yeah, I'm Spider-Man now. So you can see me. I hope this gets you interested and you do all these things that we learned. One more thing that you can do is, okay, let me close this first. Back press escape and this gets closed. Okay. So one more thing that you can do is, you can, if you want to test yourself, what you can do is you can write this loop, and you saw I did some particular operation. You can do more operations. You can even go to OpenCV and see, you can search, okay, how do I do this? How do I do this? And then do all those operations right here. Okay, so this is right now, right here it gets very interesting. And what you can do is you can like make different filters. Okay, let's do it. Let's do that. Wait, I have the script ready. Let's do it. Wait, last thing I promise. CLS. You can image annotation, wait for basic image annotation, image enhancement, enter. It's not here. Wait, let's see official tool. Yeah, there is a lot more things that we can do. Maybe later. Even this is not even that advanced. We can do even more advanced things if you obviously are interested later. Okay. And I can show you. Okay, let me show you the script first. Okay, so this is the script. We're using camera filters. This is a while loop, and there are this canny. We'll discover. I will show you about this canny and these. Maybe I'll show you about features and in the next session. And you can write a script like this. Okay, you can write a script like this. We'll do it next time, but I'm just telling you this so that you, if you want to open the camera and do all these effects on your live image and see, okay, what kind of effect every effect is having. You can crop, you can change color spaces, you can change HSV particular values or RGB particular values and see the effect on an image. This way, it will be more interesting to learn. So there are these different filters, and this is your whatever keyword you press, that filter will be applied to your uh, image. We'll discuss this in detail the next time, but in case you want to do it today or tomorrow, or this week, I would recommend doing this so that you, like when you will see all these things, it will set in more. Okay, I will go to this folder. Yeah, I'm already in this folder. Okay, now what I will do is I will write Python I will run this file, Python 07 camera filters dot py. Okay, so this will start. Hopefully, yeah, this has started. Now we can see if I want to do canny, I press C, and what canny is, it is the edge detection algorithm. This is how you detect edges. It measures the change of pixels. You can see my hand here, edges. This is also used to, yeah, you can see edges. You can, there is no other information, but you can see my outline. So what is, this is a canny edge filter. This is one of the important filters. You can see where my t-shirt ends. So wherever we have edges, wherever the color is changing from one color to another color, is this detects the edge there. Okay, maybe you can make an app to read हाथों की लकीरें and using this. Yeah, okay. So yeah, so there is you can use blur. You can see this blur. The image is blur, and all these things are important. And one more interesting that I may say you, I must tell you that this is the current image is getting blurred, right? So there are even deep learning algorithms now that try to do the inverse of this. Like whenever you have taken an important photo and oh my god, due to some reason the camera was shaken and the image is blurred. So now there are even computer vision algorithms and deep learning models which try to do inverse of this. So they correct your image. If you have a blurred image, they will change it into an unblurred image using somewhat inverse of this. Okay, and this is detecting features. I have not worked with this before, by the way. Yeah, so this is detecting features. This may be used for face recognition or P. Yeah, this is my original. This is scanning again. Okay, so that's it for today. Please give me feedback. I would be looking forward to the feedback. Wait, let me close all of this. And close this. Wait. I hope this was interesting, at least got you interested in some of the things. Yeah, that would be it for today. Thank you. I don't want to overburden you, or even for that matter, myself, because
Thank you, sir.
no
Thank you,
problem.
sir.
No problem. I hope you saw some.